Okay, the next one is 4C. Arrange the following compounds in their correct order of increasing boiling points. We have propanol, we have 2, 4, 6, 7, heptane, we have 2, 4, butane, it's supposed to be 3, butane. Okay, good. And you are asked to arrange these compounds in order of increasing boiling points. That means the one with the highest boiling point will come last, right? Good. Remember what I told you. When you are asked of boiling points, arrange objects or compounds in order of boiling points, melting points, you think about intermolecular forces, because covalent compounds, if you melt or boil them, what you are breaking is the intermolecular forces, okay, not the covalent bonds. Now, also remember that I told you we have intermolecular forces like van der Waals or London dispersion forces, as people may call it. Van der Waals forces. Van der Waals, let me shorten this. You can check your notes for that. Van der Waals forces. Van der Waals. Okay, you remember Van der Waals. Then you remember dipole-dipole attraction, which I told you occurs in polar compounds. You remember hydrogen bonding, dipole-dipole. Okay, hydrogen bonding, yeah, a special type of hydrogen bonding, a special type of dipole attraction. Okay, I believe you remember all this. Okay, now again, we said that in alcohols, since we have O attached to oxygen attached to carbon, so let me focus on this point. We have oxygen. I'm going to expand only this end, please. Oxygen attached to carbon. Okay, then I'll leave this as R. Okay, oxygen attached to carbon. Then this one is alkyl group completely. This one is alkyl group completely, so we don't have a problem here. Here, this is a polar compound because there is a dipole existing between carbon and oxygen. Okay, remember what dipole is? You check your notes for that, or you watch my videos, okay, on intermolecular forces, and you will see this. Okay, and there is also another dipole here because oxygen is attached to hydrogen. When a highly electronegative element is attached to hydrogen, you have dipole. If it is attached to another less electronegative compound, you still have dipole. So in this compound, if you have a sample of this alcohol, this is propanol. Let's say this is the alcohol. If you have a sample of this in a compound or in a beaker, sorry, that means you have millions of these molecules. You have millions of these molecules in that sample. There is a force of attraction between the dipole here, the dipoles here, okay? The same thing goes for here, positive, negative, positive. Good. So there is an attraction, positive, partially negative, partially positive. There is an attraction between this positive, partially positive terminal of carbon with the partially negative terminal of oxygen. The same thing happens between this oxygen and this carbon, okay? Between this carbon and this oxygen. We call this dipole-dipole attraction, okay? Because it's an attraction between two partially opposite charges, okay? Now, there is also an attraction between the hydrogen, which is partially positive, and the oxygen, which is partially negative. Oxygen, which is partially negative, and hydrogen, which is partially positive. And this we call hydrogen bond. So you check our video on hydrogen bond. So here we have dipole-dipole attraction between the molecules and also hydrogen bonds between the OH group of the molecules. Hydrogen bonds between the OH group. And these bonds are stronger than the van der Waals forces. The van der Waals forces exists in purely covalent molecules, okay? So let's take this as example. This is heptane. It is not polar. It is a non-polar molecule. Why this is a polar molecule, okay? This is a non-polar molecule. There is no dipole attraction between them, okay? Good. And in this kind of molecules, purely covalent molecules, what we have existing between the molecules are van der Waals forces. So assuming we have a sample of this, let me use this please to make things easier. This is the first chain, this is the second chain, this is another chain, this is another chain, okay? The force of attraction existing between this chain and this chain, this chain and this chain, this chain and this chain is what we call van der Waals forces. Van der Waals forces or London dispersion forces, as some people may call it, okay? The same kind of force exists here, okay? Let me draw this one. This is the chain, this is the chain, this is the chain, this is the chain, okay? Now, the force of attraction between the molecules of this polar compound is also van der Waals forces, okay? Very weak, weaker than dipole attraction. So when we try to melt this compound, propanol, we are trying to break these intermolecular forces, and this is stronger than van der Waals. So it will take more energy to break this bond. It will take more energy to break the dipole-dipole attraction and hydrogen bond than it will take to break the van der Waals force. So because of that, you have to supply a lot of heat or more energy to boil this. Therefore, this has the highest boiling point, okay? This has the highest boiling point because of the dipole-dipole attraction and hydrogen bond. Then coming to these two compounds, they have the same kind of van der Waals, the same kind of intermolecular forces, which are van der Waals forces. Now, in this case, remember what we said. The longer the chain, the stronger the van der Waals force, okay? Good. The chain length of this one, heptane, is longer than butane. Therefore, the van der Waals force here is stronger than the van der Waals force here. Therefore, this one also have a higher boiling point than this. So the one that has the least boiling point is butane, okay? Then this one has, so if I'm to arrange this thing in order of increasing boiling point, then our propanol, is it propanol or pentanol? Our pentanol has the highest boiling point followed by the heptane, then followed by, this is less than, by the butane. Okay, so butane has a lower boiling point, lower than heptane. Heptane is lower than penta. No. Okay, good. Propanol, please. But it's still the same thing. But the structure in the compound in the question is propanol.